तो स्टार्ट कर देते हैं। स्क्रीन नजर आ रही है? अच्छा, एनीवे, सो यहाँ से स्टार्ट कर लेते हैं कि उसके ऊपर रिकॉर्ड भी कर रहा हूँ साइमल्टेनियसली। सो व्हाट्स हैपनिंग इज के कहाँ तक किया था हमने? we did isomers, and the last thing that we did was we had started. Just one second. So we had started talking about alkenes and benzene, and we're going to do some comparison of alkenes with benzene. So just give me 1 second. So the first thing that we did when we started talking about alkenes was, I told you that I told you that alkenes had these had sp2 hybridization. With the carbon atom, it's 4 electrons. 3 of them, they were making these normal bonds. They were getting pulled by 3 different atoms, and it was fan shaped. So it was making 3 normal bonds, 3 sigma bonds, and they were sp2 hybridized orbitals. And the 4th electron of carbon was unchanged. It was an unchanged p orbital. And तो 3 की शक्ल change हो गई थी. They became sp2 hybrid orbitals, and one of them, it remained unchanged. And that's how you got double bonds. That's how you got pi bonds, that the carbon atom with its sp2 hybridized orbitals, वो 3 normal bonds बना रहे हैं, and the 4th electron is overlapping with the other carbon atom's 4th electron, and it's forming a pi bond. And the same thing was happening with benzene. I explained to you that in benzene, carbon is again making double bonds. So that is one way. That's the Kekuले structure of benzene, which is that carbon is in a hexagonal ring, and each carbon atom is making double bonds. So they're all making double bonds and alternatingly. And what happens is, this is the actual structure, that the double bonds, they kind of get mixed up, which is why that is represented by a ring. So always remember this ring. Another way to look at it is to think of it as alternating double bonds. And you had, this was the skeletal formula of that. So uske structure ko humne jab describe kiya tha na, so I told you that it's the same carbon atom, sp2 hybridized. Like if you look at this carbon atom, 1 bond with hydrogen, 1 with this other carbon atom, 1 with this carbon atom. So it's 3 bonds. Each carbon atom is making 3 normal bonds. 4th electron jo hai, that ends up overlapping. I mean, each carbon atom, it's making 3 normal bonds, sp2 hybridized carbon orbitals, and the 4th electron is unchanged, and it overlaps with the neighboring carbon atoms and ends up forming pi bonds. But the thing is that the pi bond formed is going to be very distributed. This orbital is not only going to overlap with the orbital on the left side, but it's also going to overlap with the orbital on the right side. तो इस तरह क्या होता है कि उसकी जो electron density है, that gets distributed. So the electron density is a lot lesser in benzene, because the electron of this carbon atom. हाँ जी,
ये एग्जाम में बेंजीन का स्ट्रक्चर डिस्क्राइब करना होता है कि आई मीन क्या करना होता है?
हाँ, बेंजीन तो मेन इंपॉर्टेंट चीज है. उसके ऊपर क्वेश्चंस आएंगे, 6 मार्क के क्वेश्चंस आते हैं टू डिस्क्राइब व्हाट बेंजीन इज. तो
आप कैन यू एक्सप्लेन इट अगेन प्लीज?
चलो मैं क्विकली उसको ना जल्दी से ड्रॉ भी कर लेता हूँ कि किधर गया हमारा कार्बन एटम. ये तो क्लियर है ना, sp2 हाइब्रिडाइज्ड कार्बन एटम, राइट?
sp2, yes.
कि in sp2 carbon is making 3 normal bonds. तो उसके 3 electrons, they're getting pulled in 3 different directions. ठीक है? So the 3 electrons, and the 4th electron is not doing anything, right? वो उसका p orbital जो है ना कार्बन का, वो उसी तरह है. तो ये so that's the sp2 hybridized carbon atom, right? बेंजीन में ना इस तरह के 6 होते हैं. इसको थोड़ा सा छोटा कर लें इसको. अच्छा, बेंजीन में ना इस तरह के 6 होते हैं. So let me just draw 6 of them. All of them are going to be sp2 hybridized. So that's the second one. ये दोनों आपस में overlap करेंगे, they would end up forming a bond over here. इनकी जरा directions अच्छा, so they're going to end up forming a bond. अच्छा, फिर there's going to be another carbon atom which is going to be exactly the same. वो जाके इसके साथ bond कर लेगा, ठीक है? तो सारे carbon atoms are all bonding to each other, ठीक है? And then there's going to be another one, and वो कैसा करेगा? That carbon atom will, अच्छा, that carbon atom will also bond. तो इसने जाके ना इधर bond कर लिया, ठीक है? और फिर एक और नहीं, दो और चाहिए. So there's this other carbon atom. This ends up bonding with this one, and you need one more carbon atom. So इसको रोटेट कर लो. इसके जो दो sp2 हाइब्रिडाइज, तो इन दोनों ने आपस में दे वुड ओवरलैप, राइट? तो ये क्लियर है, ये पहला स्ट्रक्चर बना है, ठीक है? इज दिस क्लियर? ये बात क्लियर है?
जी सर, यस.
और इधर ये जो बाहर इलेक्ट्रॉन खींच रहे, कौन खींच रहा है? इट्स द हाइड्रोजन दैट्स पुलिंग द इलेक्ट्रॉन आउटसाइड, राइट? और होता क्या है? what happens is कि वो चौथा इलेक्ट्रॉन तो रह गया ना, ठीक है? the fourth electron is still left. So what will happen is कि जो चौथा इलेक्ट्रॉन है, that one is going to end up overlapping with the neighboring carbon atoms. Just one second, इसको इधर ही overlapping show कर देते हैं. तो orbitals अगर parallel में आ जाए तो what will happen? They would end up forming pi bonds, right? Is that clear?
जी सर.
तो double bond होना चाहिए ना, right? Just like this double bond over here. They're going to be alternating double bonds, right? कि वो सारे orbitals parallel में. So this would overlap with that one, and they would form a double bond over here. This is going to overlap with this one. They would all form double bonds. ये इसके साथ करेगा, ठीक है? और ये वाला, it's going to overlap with this one, right? So they're going to be three double bonds. But the thing is, and this is what I was explaining, okay, double bonds are not going to be localized. It's not like if this carbon atom is making a double bond with this one and overlapping, it's forming a pi bond with this one. So it can very well overlap with this one as well. Ibrahim, ये clear है बात?
जी सर.
तो end result ये होगा कि they would all end up overlapping with each other.
सर लेकिन आई मीन एक बॉन्ड तो बना चुके हैं. व्हाई वुड बी ओवरलैपिंग विद, मतलब फिर तो ऐसे इट वुड बी ओवरलैपिंग विद टू ऑर्बिटल्स. वन ऑर्बिटल इज ओवरलैपिंग विद टू ऑर्बिटल्स.
हाँ, तो बेसिकली उसका इलेक्ट्रॉन ज्यादा डिस्ट्रीब्यूट हो जाएगा ना, कि दिस कार्बन एटम, क्योंकि बोथ एटम्स वुड बी ट्राइंग टू पुल द इलेक्ट्रॉन, क्योंकि p ऑर्बिटल नीड्स एन इलेक्ट्रॉन, राइट? कार्बन का जो फोर्थ p, तो ये इधर खींच रहा होगा, उधर खींच रहा होगा. तो व्हाट विल हैपन इज दैट द एंड रिजल्ट वुड बी दे वुड ऑल एंड अप ओवरलैपिंग. या आप कह सकते हो, व्हाट यू कैन स्टेट इज that the double bond will not have a specific position. Sometimes it's going to form a double bond over here. Sometimes it's going to form a double bond over here. So basically what's happening is there's going to be a ring of delocalized electron cloud. Is that clear?
Yes.
Achha, so the main point about this benzene structure was that the electron density is more distributed and it has a lower charge density compared to alkenes. So this is not like a double bond in alkenes. The electron density is a lot lesser compared to an alkene. Alkene के अंदर क्या था? कि alkene के अंदर the electron density was very concentrated at a very specific point, क्योंकि there was only one double bond. Is that clear as well?
Yes, sir.
तो यहाँ पे ये नहीं है. यहाँ पे ये कि इलेक्ट्रॉन मतलब तो ये कि इलेक्ट्रॉन डेंसिटी इज वेरी कॉन्सेंट्रेटेड एट अ वेरी स्पेसिफिक पॉइंट, बट over here the issue is the electron density is a lot lesser. तो benzene के reactions are going to be different compared to alkene reactions. Why? Because भाई म्यूट कर लो, वो स्पेस दबा के ऑन कर लिया अगर वो शोर आ रहा है. अच्छा, Sam, is this clear? Hamza, is this clear?
सही ये आप जो कह रहे हैं तो आई मीन एल्केन्स में भी ट्रिपल sp2 हाइब्रिडाइज्ड है और ये बेंजीन भी sp2 हाइब्रिडाइज्ड है तो
Huh,
फर्क क्या है
so alkenes and benzenes are kind of the same thing, except that the electron density is going to be a lot stronger in alkenes because the electrons are concentrated at this point. They're not distributed. Either the issue over here is that the electrons are distributed. The electrons are getting distributed. I mean, one of the p orbitals is not only overlapping with the carbon on the left side, but it's also overlapping with the carbon on the right side. So the electron density is a lot lesser. Is that clear?
yes, yes.
So that's the major difference. Otherwise, they're kind of very similar, but that's the major difference. Electron density is a lot higher over here. Electron density is a lot more distributed over here, which is why the reactions of benzene are going to be slightly different compared to alkenes. They're going to be sometimes very similar to alkenes, but they would also be very different from alkenes as well. So firstly, now let's study the reactions of alkenes. Then we'll jump to benzene. This one we already did, that bromination or chlorination of alkenes. That was the first one, and this was the mechanism of the reaction. And remember, they always do a comparison with the alkenes. So the electron density in alkenes is very high. Alkenes have electrophilic reactions. What's an electrophile? Electrophile is a substance, is a species that is attracted to negative charge and can accept a pair of electrons. So bromine molecule comes in, it gets polarized because the electron density is really high. So the molecule of bromine gets polarized, the electrons in the bond get pushed away. This one becomes negatively charged, this one becomes positively charged. The positive one grabs all the electrons in the pi bond and bonds with them. So it forms a bond. The carbon on the other side becomes a carbocation, and Br minus one then goes and bonds with it. So that was the mechanism that you studied. And the conditions for this reaction were RTP, and you didn't need any light for that. It was absence of light, and it happened at room temperature. Now the thing, और भी कर लेते हैं. What are the other reactions? Let's do all of them just for revision. The other reactions of alkenes were that you had reactions with I'll just quickly write. They all had the same mechanism. They would follow the same mechanism. So you had hydrogenation and hydration, and with hydrogen halides as well. So the second reaction was hydration, where you had, okay, it was a reaction. That was a reaction with water. And the reaction was that you needed, the conditions for that reaction were that it was 300 degrees centigrade, 60 atmosphere was the pressure, and the catalyst was concentrated phosphoric acid or phosphoric acid.
पेपर 5 तो एग्जाम्प्ट हो गया ना आई गेस
क्या?
पेपर 5 तो एग्जाम्प्ट हो गया ना सिर्फ पेपर 4 ही होगा हमारा
हाँ, लेकिन चॉइस है, वो स्कूल्स पे डिपेंड करता है. ठीक है, तो आपका स्कूल अगर एग्जाम्प्ट कर रहा है तो फिर एग्जाम्प्ट है. चॉइस मिल गई लेकिन आप लोगों को, ठीक है, बट इट डिपेंड्स ऑन द स्कूल. और मैं स्कूल में प्रेशर डाल देना, एग्जाम्प्ट करवा लो तो बेहतर है. So ये वाला ये जल्दी से कर लें कि you've got a double bond, and so this is so that's your propene molecule. Water is going to get added to it. Or what was the rule? What was that rule that where would the H get added to?
Markovnikov's rule, I mean, to the carbon that's already bonded to most hydrogen.
Okay, so in this case, especially for an unsymmetric alkene, a symmetric is, there's no issue for symmetric. So for unsymmetric, so unsymmetric alkenes, the H will get bonded to the carbon that's already bonded to more H, and the OH will get bonded to the carbon that's bonded to fewer H. That's going to be your major product. And you'll also have a minor product, which is going to be the exact opposite. Okay, the carbons. So you had H. And the other one was that the H will get bonded to the carbon with fewer hydrogens, and OH will get bonded over here. So that's going to be your minor. So that was your minor product. And this was remember the Markovnikov's rule, you still have to, everything would come, you have to revise everything about AS. So Markovnikov's rule was simple H likes to bond. So it likes to bond with the carbon that's already bonded to more H atoms. और इसकी रीजन भी पढ़ेंगे, वो रीजन the reason behind Markovnikov's rule. Okay, let's quickly do that. What was the reason for the Markovnikov's rule? कोई याद है?
जी
No.
सर, वो सेकेंडरी जो हमारे पास कार्बोकैटायंस दे मोर स्टेबल, तो इट प्रेफर्स दैट.
ठीक है, so basically ठीक है, the simple reason was the secondary or tertiary carbocations are going to be more stable. And why were they more stable? बल्कि Markovnikov's rule का करना है.
Because of the fact that electron donating effect, so charge density come.
Secondary or tertiary carbocations had more electron donating alkyl chains. Electron donating alkyl chains, and because of that they had more alkyl chains, and because of that the charge density on the carbocation decreases. It decreases, and you have a more stable carbocation. So basically this was what was happening, that if you had a propene molecule in an unsymmetric alkene, you had a double bond, and if you remember the mechanism, the bromine is going to grab electrons from the double bond and bond with the carbon atom. So it could do that. It could either steal electrons in the double bond and bond with this carbon atom, and this carbon would become positively charged, or the bromine could steal electrons from the double bond and bond with the other carbon atom. So it could bond with the carbon on the right side, and this carbon would become a carbocation. So this one, the one on the right side, is going to be more stable. So that is the one that's going to be more stable, and the reason is that the positive charge on this carbon atom is going to be smaller, the carbocation. This positive charge would be a lot smaller because it's surrounded by large groups. It's got a carbon chain over here, it's got a carbon chain over here, so it's surrounded by a lot of electrons. So all those electrons are going to get, because carbon has 6 electrons, so there's a big group on that side, and there's a big group on this side with lots of electrons, like CH3 has 9 electrons. Over here, you've got CH2Br, so there's lots of electrons around it. So the charge is going to be smaller. And in the other case, the carbon is surrounded by hydrogen atoms and by more hydrogen atoms, and hydrogen doesn't have electrons. So the charge over here would be, it's not surrounded by a lot of electrons, so the charge over here is going to be larger. Or if the charge is larger, what will happen is that this positive charge, if this is big, it will not allow the bromine to take the electrons in the first place. So iske electron ko pakdega and it's going to pull that electron back and attract that electron strongly. So it won't allow the bromine to actually steal those electrons in the first place. And it will hold on to its electrons. But in this case, the carbon atom will allow the bromine to take away electrons from the double bond. Like you had a double bond over here, and bromine would be able to pull electrons away from it. Why? Because the positive carbocation can get electrons from other places because it's surrounded by very large groups. So remember, if the carbon atom is surrounded by carbon chains, it's got more carbon chains, it's secondary or tertiary, then it's going to be more stable. ठीक है, बाकियों clear है? Is this clear? Hafza, is this Bazga?
Yes, sir.
Yes, sir.
So this is all about Markovnikov's rule, which you have already studied in AS. And you had the reactions with HCl and HBr and HI as well. So let's, I'll just do one of them just to get over them so we can move towards benzene. As anyways, you had reactions of alkenes with hydrogen halides. They didn't have any special conditions for this. So the same Markovnikov's rule would apply to this as well. And so if I have a propene molecule, remember no special conditions need to be remembered for this one. And if I reacted with HBr, then again, I'm going to get two products. I'm going to get a major product and I'm going to get a minor product. So I've got CH3C with double bond that will go away. The major product would be this one, that the H gets bonded to the carbon atom that's already bonded to more H, and the Br gets bonded to the carbon atom with the fewer hydrogen atoms. That's your major one, and the other one is going to be, so the other one is going to be this one, that here's your propene molecule with the double bond in the middle. The H will get bonded to this carbon atom and the Br will get bonded to this carbon atom. So that's your major product. And that's your minor product, or sorry, एक reaction रह गया, which is hydrogenation. Let's quickly get over that. So hydrogenation is kind of the same thing. So I'll just copy this. I'll just do one reaction quickly. So in hydrogenation, you had an alkene. Iski kya conditions thi?
Nickel as a catalyst and high pressure.
Okay, so nickel, palladium, plus 200 degrees centigrade or 150 degrees centigrade, that's it. No pressure, okay? And H2 gas was needed, and you'll have. So what was the significance of this reaction? Why was this reaction important in the from an industrial point of view?
I mean, production of margin.
Okay, so you had unsaturated vegetable oil. I mean, natural vegetable oil, which had double bonds in them. And you could convert them into margarine. Like, what's the difference between, what did the addition of hydrogen do to this? Like, what's the difference between unsaturated vegetable oil and then you add hydrogen to it?
States. I mean, it's
हाँ,
solid.
तो hydrogen add करने से क्या फर्क पड़ता है?
Bonds single sp hybridization.
नहीं, वो तो चलो ठीक है. Adding H2 what it will do is will make the molecule bigger. And if the molecule is bigger, what will happen? There's going to be more van der Waals forces. And the melting point will increase. So whenever you want to make the melting point slightly higher, what you can do is simply add H2 to it, and all the double bonds would be gone, and the molecule would become unsaturated, and it would just have a higher melting point. That's it. Okay, so this was all about alkenes and their electrophilic addition reactions. Remember, all of these reactions, they were electrophilic addition reactions. They kind of had the same mechanism. The electron density was very high, so I'm focusing on this, that it had a very strong electron density. The pi electron clouds were concentrated over this area, and the bromine molecule would get polarized very quickly. Now we're going to move towards benzene. So what's the difference in benzene? The first thing is benzene is going to have a similar reaction, but the name of the reaction and the mechanism of the reaction is electrophilic substitution. So it's going to be an electrophilic substitution reaction. अच्छा एक benzene हम copy कर लेते हैं वहां से कि what let's copy, which one looks good? I mean, let's copy this one. So remember, what's the difference between alkenes and benzene? Benzene has a lower electron density. It's got a much lesser electron density. The electron cloud is a lot more distributed. It's got a lesser charge density. So if I copy a benzene, and what I'm going to do is I'm going to take this benzene and I'm going to try and react it with bromine. So we're going to focus on the mechanism, what's going to happen. So why is the reaction of benzene also electrophilic? What's the reason for that? Like what's the reason? Why do electrophiles get attracted to this?
Pi electron cloud.
Okay, so it's got a pi electron cloud, and because of the pi electron cloud, electrophiles are going to get attracted to it. So the same thing kind of happens. A bromine molecule comes in and it gets polarized. So here's a bromine molecule that's coming in. So there's your bromine molecule that's coming in with its which is non-polar initially, and it's coming in and coming close to the benzene molecule. What will happen? Because of the electrons over here, the electrons in bromine are going to get repelled. They're going to be pushed away. This bromine would become negatively charged. This bromine would become positively charged, slightly positive. And it's going to be, I mean, the positive bromine is going to be attracted even more to the electron in benzene, at least one of them, like at least one of the p orbitals, right? Is this clear?
Yes.
Okay, so the first step is kind of the same as alkenes. You had a pi electron cloud. The electrons over here, they got pushed away. The positive bromine got attracted to the electrons in the pi electron cloud, and the negative bromine got further repelled. Now coming back to this, so the molecule is getting polarized, right? Is the polarization going to be larger or lesser? Like, are the electrons over here going to be pushed very strongly to the right side away from benzene, or is the polarization going to be lesser?
I mean, lesser.
Lesser.
Lesser, because the benzene electron density is a lot lesser, because this electron over here is not only getting distributed on the top side, but it's also overlapping with the carbon on the left, on the bottom side. So the end result is the electrons are a lot more distributed. So पहले तो ये लिख लेते हैं कि benzene's pi electron clouds, benzene's pi electron, or we can say pi electron cloud, or the ring of benzene. Polarizes the bromine molecule. So it polarizes Br2, but the polarization is lesser compared to alkenes. So the polarization is lesser compared to alkenes. And because of the lesser polarization, the reaction does not actually happen. I mean, the positive charge over here is a lot lesser. So I'm going to shrink it. And the negative charge over here is also a lot lesser. So the attraction over here, this one, it's not that strong. It's a very, very weak. It's a very, very weak attraction. Is this clear? At the moment, there's no reaction because the polarization is lesser compared to alkenes. Is this clear, this thing?
Yes.
Yes, sir.
Hafsa, Sam, is this clear? So this case, so the polarization is a lot lesser. Now, in the previous case, the reaction would happen at RTP. Nothing, I mean, this reaction, you add bromine, you didn't even need light. I mean, obviously you didn't need light because there was going to be a free radical substitution reaction otherwise, but it happened at RTP room temperature. No special conditions were needed. Now, over here, you would need some special conditions for this reaction to happen. And those special conditions are that you would need a catalyst. So you're going to add a catalyst, and that catalyst is FeBr3. So FeBr3 is going to be added. Now, what these catalysts do is that they, even in transition metals, I did explain this, that when you have a transition metals have large number of protons, like iron has 26 protons. So these transition metal atoms, they have this very weak tendency to attract electrons. So what will happen is that the iron on the other side is going to try and pull the electrons towards itself. So iron over here is going to help bromine get polarized. So this one over here, this electron cloud over here is pushing the electrons while these electrons are getting attracted by the iron from the other side. So now the polarization would increase. The negative charge over here would become bigger. The positive charge over here would also become, it's going to become bigger. And if the positive charge becomes bigger, so it's going to get even more strongly attracted to. So now the attraction would increase because the polarization is becoming bigger. And at the end of the day, the molecule will kind of break in the middle. The electrons over here, not only are they getting pushed by the benzene electron cloud, but they're getting attracted by the iron on the other side. The 26 protons of iron are attracting. So these electrons are going to get pulled towards iron. Is that clear?
Yes,
clear?
sir.
ठीक है, Bhaskar, clear? Hafsa, is this clear?
Yes, sir.
इसको complete कर लेते हैं बाकी reaction. So remember, okay, this reaction will not happen without a catalyst. Under certain आगे जाके detail में पढ़ेंगे, there would be some scenarios where it will happen, but we'll talk about that later. So the next step is, what's the next step? Let's just quickly complete the mechanism, ठीक है? So let's move to the next step. And let me just rub this all off. So now the next step is the bond breaks. So this bromine over here is going to take its electrons, and those electrons are getting attracted to iron. It's going to get pulled by that iron. And remember, the bromine has a negative charge, and it will end up forming a dative bond because it's going to be attracted to iron. And this entire thing will have a charge of -1 because the Br that came had extra electrons. So it's now going to have a -1 charge. Is that clear?
Yes.
And when the electrons leave, this bromine gets a +1 charge. So this +1 is looking for electrons. So what it does is it sees the p orbital of this carbon atom, the green one, right? At the moment, the electron in the green orbital over here was not only getting pulled by the or overlapping with the other carbon atom, it was also overlapping with the carbon over here. But now the positive bromine, the bond has broken, so let's get rid of that. So the positive bromine is going to get, the electrons are going to get attracted to the positive bromine. So these electrons will stop the overlapping that's happening. दोनों साइडों पे. ठीक है, so the overlapping will stop, right? So one of the p orbitals is now missing. Where did that p orbital go? Because that p orbital got attracted to this Br positive. So the Br positive is going to come in, and the fourth electron of carbon is going to bond with this Br. And the Br would no longer be positive because it got its electrons, right? Is that clear?
Yes.
Yes, sir.
अब फिर next चीज है कि this benzene electron cloud is now electron deficient because somebody took its electron, right? So this benzene now has a positive charge. So this benzene over here has a positive charge on it. So it's got a positive charge. And the benzene electron cloud is unstable now. It needs that electron back. So who's willing to give electrons? Like bromine came in. Now bromine is electronegative, so bromine doesn't want to lose electrons. But you've got an H over here. H has a very high tendency to actually lose electrons. So the next step would be, and the last step would be, okay, I mean, H is always ready to lose electrons. So the last step would be that the electrons that are over here, they would be given back to the benzene electron cloud, and the H would be lost. And the H will get its electrons from somewhere else. And that somewhere else is it will eventually get electrons from this bromine. लेकिन उस पे हम बाद में आते हैं, ठीक है? The first thing is benzene is looking for its electrons because the electron somebody stole its electron. So it sees H is very electropositive. So the end result is that the electron cloud would become complete again. So the last step would be, किधर गया जल्दी से last step बनाए. So now the last step would be the p orbital comes back and the H is lost. So these electrons, they come back. The H +1 is released. And where do the electrons go? The p orbital, a second. So the p orbital comes back क्योंकि उसको ये electrons वापस मिल गए. So it got the electrons. पता नहीं what's happening here, just a second. अच्छा उस पे बना रहा था मैं. इसको सही कर लेते हैं. अच्छा H सारी गलत हो गया. अच्छा ये कर लेते हैं. H चला गया, ठीक है? The H is gone. The electrons are back. So these electrons are back and the p orbital is back. So the p orbital is back. And इस bromine को भी जगह पे लगा दो, ठीक है? So the bromine is also So the bromine is also, the bromine is left. And that is a substitution that's happening. And the pi electron cloud is also going to be formed back again. So they would start their overlapping again. तो ये बस अब खत्म हो गया, ठीक है? So that's about it. और फिर वो जो H टूट के अलग हुआ ना, what that H would do is, that H, this tiny H over here, which is positively charged, will team up with the Br-1 that was lost earlier, and they would end up forming HBr, and the FeBr3 catalyst would be reformed. So that H would go, and it's going to get back the Br-1 that was lost earlier. And that's it. और ये पिछले वाले को मैं सही कर लूं कि let me put the H. अच्छा, is this clear? This thing?
Yes, sir.
So मैं बस जल्दी से quickly बता दूं कि क्या हुआ था, polarization was not possible because the electron density was very less. So you needed a catalyst which was FeBr3. Iron, हाँ जी.
Like initially, this pi electron cloud was not like strong enough to pull the Br positive, so we added a catalyst. So when Br is added, how, like, even though like there's still electrons, how did it become like positively charged, like strong enough to pull electrons from H at the end? How?
I mean this one?
Yes, the middle stage. Like it took the electrons from H to complete its pi electron cloud. So how did this positive charge become strong enough to like pull those electrons from H?
नहीं, क्योंकि the thing is कि H is very electropositive, right?
Oh,
So
okay.
H is the one that's willing to lose electrons. So it can get those electrons back from H. ये मतलब यहाँ पे arrow भी होना चाहिए था, ठीक है? Just a second. Middle वाले में, where's the middle part? तो इस जगह पे there must be, there should be. अच्छा, इसका जो पेपर के अंदर मैकेनिज्म बनाना है ना, वो तो मैं एक्सप्लेन करता हूँ, ठीक है? So these electrons, they come back. अच्छा, anyways. So this is the detailed mechanism. This is obviously not the one that you're going to draw in your paper, but remember, we're going to do a lot of electrophilic substitution. So this is what happens in electrophilic substitution. The next mechanisms that I'm going to draw, I'm not going to show this in that much detail. I'll just draw the simple mechanism that is required for the exam. But for once, I've actually drawn this in a lot more detail. ठीक है, ये सारा clear है? This one.
Yes.
चलो ठीक है, फिर इसका ना वो नेक्स्ट टाइम जो करेंगे वो करेंगे कि पहले तो इसकी सिंप्लीफाइड वर्जन के पेपर में किस तरह लिखना है, और दूसरा ये कि इसकी फिर डिफरेंट वर्जन्स होंगी, तो वी गोना टॉक अबाउट दोस, ठीक है? तो फिर नेक्स्ट क्लास में कंटिन्यू करते हैं, ठीक है? ओके देन,
अल्लाह हाफिज़।
हाफिज़।
Allah Hafiz.